Hey guys, so I just went over in the previous video on how to solve for the concentration when you're dealing with an expanding gas, but I didn't do a very good job, as I would have liked to, discussing what is known as the expansion factor. So let me rewrite the whole equation for concentration that we found, which is like this. What the heck? Okay, sorry. Here, I'm just writing the equation from above. Okay, there we go. Your pressure variable, your temperature variable. Okay, so the expansion factor is the new thing right here, right? And didn't we agree that, hey, it's equal to the molar fraction, or molar fraction of A at the initial condition times the gamma. So it's important to know what gamma is, and I think that this one was straightforward, but we deduced that, hey, that's going to be equal to FA sub naught over FT sub naught, and that happened through division. I could roll up here and show you where that happened. Where are you at? Where are you at? There it is. See it? Right here. And that's what we called gamma. Or no, sorry, the mole fraction. Okay, so coming down here, let's take another look at it. What does the gamma mean? What's this? Right? So I was a little wrong on the way I defined it, but it's nothing unrepairable. So this is the moles total change. Moles total. So if you had A goes to B plus C, it's going to be the moles total change. And over here on the bottom, it's 1 mole of A reacted, right? So here's the thing. When 1 mole of A reacts, what's the total change, right? So then you have 2 on this side. Well, if you have 2 to end with, 2 end, 1 start, when you react 1 mole, you get 2 in the end. The change is 1 extra mole. And therefore, your gamma is then going to be defined by saying 1, right? If you did it the other way, A plus C plus B, really should be B plus C, whatever, like this, you start with 3 moles and you end up with 1 mole, which means the change is going to be 1 minus 3, negative 2. So then your gamma is going to be negative 2 for total mole change with 1 mole of everything to start with, right? So then it'd be negative 2. So we could do another example just to put it in concrete. Right? So what's the gamma here? We have 2 moles reacting and then 2 moles forming. So 2 minus 2, this guy minus this guy, gives you 0. So then your gamma equals 0. And that's what happens when you have equimolar, if you want to look at it like that. I'm not sure if that's a term for it, but equimolar. So then what does equimolar do to your equation? Right? That's a very good point. So let's see if I memorized it. CaO 1 minus X. Wow, I'm good. I think. Oh god. Okay. Did I get that right? You write it that many times, it becomes naturally, right? Okay. So if E is equal to 0, because E is equal to gamma times Y, and if I wrote that wrong, didn't I? So sorry. Gamma, if your gamma equals 0, then your E equals 0, right? So then if your E equals 0, that's 0. So then, hey, look, I'm left with what you're used to, using liquids. With the exception of your pressure and temperature term staying there. Now, if you have isobaric, just to add in as a note, isobaric, this will become 0. And isothermal, this thing will become 0, because T naught will equal to T, oh, not 0, sorry. It'll become 1. Same thing over here. Because isobaric means the pressure initial is the same thing as the pressure at some other time. The T initial, same thing with the T. So then it'll be similar, and then, hey, look, it's just like you're dealing with a liquid. Right? So that's what happens when you have an E of 0, and then you have isobaric, isothermal conditions. And I hope that this definition of gamma, or even the expansion factor of E, makes sense. Okay, so yeah, I thought I'd clear that up. All right, I'll see you guys in the next video. I hope this helps, and it's a pleasure like always.